So our next form of our line is going to be the slope-intercept form of a line. Y equals mx plus b. M is going to represent the slope of a line, and then b is going to be the y-intercept of the line. And how do we put equations of lines that are in standard form into slope-intercept form? We just solve for y. Now, we've practiced solving for y in previous lessons, so we're going to practice that some more. So let's look at that. If I want to solve number 8 for y, I'm going to add 2x to both sides. Remember, these are not like terms, so that's 3y equals 2x minus 6. Then I'm going to divide everything by 3. So that gives me y equals 2/3 x. 6 divided by 3 is 2, so minus 2. When I'm graphing in slope-intercept form, the easiest way to graph is to plot the y-intercept. In this case, the y-intercept is 0, -2. And then count my slope of 2/3. That's a positive slope, so my line should lean to the right. So 0, -2 on the graph. And then from that point, I'm going to count up 2 over 3. Okay, and then I'm going to draw my line between those 2 points, and there's the graph of my line. Okay, let's look at number 9. To get number 9 solved for y, I'm going to subtract 4. So x minus 4, again, you can't combine those because they're not like terms. And then I'm going to divide by -2. So x divided by -2, remember there is an understood 1 here. So just keep that in mind. So that's -1/2 x. -4 divided by -2 is +2 equals y. So my y-intercept is 0, 2 with a slope of -1/2. And again, slope being negative means the resulting line should lean to the left. So 0, 2, 0, 2. I'm going to go down 1, right 2, or I could go up 1, left 2. You have to go in at least one negative direction when you're plotting your negative slopes, okay? But not 2 negative directions. You have to go in 1 negative direction, and then you just connect those with your line. If I want to use slope-intercept form to write the equation of a line, remember it's y equals mx plus b. If I'm given the point, x and y, and I'm given the slope, which is m, I can plug those numbers in. 3 equals 5 times -2 plus b. That means 3 equals -10 plus b, so b equals 13. Now, that's my y-intercept. To write the equation of the line, I have to then go back and say y equals m, that's 5x, plus b, which is 13. There's the equation of my line. The second thing on this screen, on this particular slide, is called the average rate of change. Please note that average rate of change is finding slope between 2 points. Okay, so you're going to find the slope. So let's say I give you the function. Let's do an easy one, x plus 3. And then I tell you that I want you to find the average rate of change between 0 and, let's make this x squared, 0 and 4. I want to find the average rate of change between 0 and 4. The first thing you're going to need to know is what is f of 0 and what is f of 4. And then you have to remember f of x equals y. So f of 0, 0 squared plus 3 is 3. 4 squared plus 3 is 19, because 4 squared is 16 plus 3. What that does is that gives me 2 points, the point 0, 3 and the point 4, 19. Average rate of change is basically slope. So I'm going to do 19 minus 3 divided by 4 minus 0. And what I get is 16 divided by 4, which is 4. So the average rate of change between 0 and 4 for my function f is 4. Continuing with that ideal of average rate of change, we can also do this from a graph. So it says determine the average rate of change from -1.50, that's a point on the graph, to 0, 2. So basically what we're finding is the slope of the line between these 2 points. Slope, average rate of change. Get those, connect those two in your brain. And I'm just going to do 2 minus 0 divided by 0 minus -1.5. That gives me 2 over 1.5. Which is equal to 4/3, or 1 1/3 if you want to write it that way. Okay, so the second question, same idea, only now I'm going to go between 0, 2, and 2.51. So now what's the slope of that line? Well, if you look at that, it's negative, so I can expect my answer to turn out to be a negative number. So this is going to be 1 minus 2 divided by 2.5 minus 0, which is negative 1 over 2.5, which turns out to be negative 2/5, or if you are doing decimals, negative 0.4. So here we're going to learn how to use a graph to solve equations and inequalities. So I have two lines on this graph, y equals 3x minus 4 in red and 0.5x plus 1 in white, in blue. And so if I want to solve the equation 0.5x plus 1 equals 3x minus 4, I want to know where these two graphs are equal. Well, they are equal at their point of intersection. They are equal at 2, 2, so x equals 2, and just an FYI, I'm looking at the x value, not the y value. X equals 2 is the solution because that is the x value of their point of intersection. Then we need to look at where is 0.5x plus 1 less than 3x minus 4. Okay, so their point of intersection, we've already pointed out, but this is asking where the blue line is less than the red line. The blue line is less than the red line to the right of that point of intersection. See, it's underneath. So what we would say the answer here is x greater than 2. Their point of intersection is at x equals 2. Then the line 0.5x plus 1 is below 3x minus 4 to the right of that. Okay, same idea, only this time we're doing the greater than or equal to. Well, where is the 1/2 x plus 1 greater than 3x minus 4? Well, it's above to the left. See, it's above to the left. So that means when I answer that question, I'm going to say that x is less than or equal to that value of their intersection, which is 2.